the force vectors experiment, what do we first do is we connect to our two vernier force sensors. Once connected, you come down to the bottom and we click 0. They need to be zeroed in the orientation that they are, so if this changes orientation, then that will change the force. What we'll then do is we'll get some slotted masses. In this case I'm using 150 grams, and you'll notice that these little metal washers, that one is fixed, it's actually glued on, and the other two are floating, and so we attach the two floating washers to the force sensors, and they attach with their other hooks, and then on this end I put that over the 50 gram slotted mass, and with that leaning over the edge of the bench so that it is free to suspend, we get something like that. And so for the experiment for the pupils, you'll be using 40 degrees, so 10, 20, 30, 40. For this example, 10, 20, 30, 40, I'm going to be using 20 degrees, and so you spend a bit of time trying to line it up so the center of the circle is inside there and at 20 degrees. What you'll then do is, in vernier graphical analysis, you can click on this button here and you go meters, because what we really care about is getting these two the same, and so you can tell that I'm not exactly right, and so you'll see that by changing that, even though I might not really be changing the angle very much there, it's a component, and so they need to be perfectly in line. The force sensor has to be perfectly in line with the string, and because they're both 20 degrees, they should both be measuring the same force, and so you just need to adjust it until that's true. The 20 degrees was quite tricky, so I set up at 30, and so you can see the strings are directly going over 30, and that they are orientated directly in. And so then what we do is we come over to our data table and we start filling it in. So that's a 30 degree angle, and if we look at our force sensor, they're measuring about 0.81 for each one, and the horizontal component is how much of the string is pulling that way, and then how much of the string is pulling that way. I really care about how much of the string is pulling vertically and how much of that string is pulling vertically, and that vertical component will be F1 cos theta, so I can try my calculator. So 81 cos 30 gives me 0.70, and that'll be the same for both of them, 0.70, and so then I can times that by 2, and I get that final column, F1 cos theta plus F2 cos theta, will equal 1.4 newtons, which is pretty close to the 1.5 or the 0.15 times 9.8, 1.47 that we're expecting. So that way we're able to show that the amount of force being pulled this way is equal to the component of that in the vertical direction in both.